everyone, I am Janapati Srinu. Who are watching first time my channel, subscribe my channel and share to your friends. We are discussing about TSCPGET and APPGCET 2022 examinations, entrance examinations. The continuations of yesterday class is electrochemistry. Now I am going to discussing about terms conductance and specific conductance, equivalent conductance, molar conductance, effect of those conductances with dilution. So we will discuss one by one. First, what is meant by conductance? So in examination point of view, mainly they will ask the units of those conductances. What happens if dilution occurs in the equivalent conductance and molar conductances? So first, conductance. Simply I am writing conductance C is equal to 1 by R, right? So that is reciprocal of the resistance. Reciprocal of the resistance is called conductance. Reciprocal of resistance C is equal to 1 by R is called the conductance, you can say. Next, if I will take one electrolytic cell, this is the electrolytic cell. If I am taking, these are the electrodes. These are the electrodes. Let's say area of this electrodes is, so that is A. That is A means area of cross sectional area. A means area of, otherwise you can say cross sectional area. Cross sectional area. Cross sectional area. And length of these two electrodes is L. L means length between the electrodes. And these are the, this is called electrolytic cell. This is electrolytic cell. Electrolytic cell. So let us say R is directly proportional to length. So resistance is directly proportional to length and inversely proportional to area of cross section. That is equal to R is inversely proportional to A. So simply R is directly proportional to length, R is inversely proportional to area, R is directly proportional to 1 by A, you can say. So by combining these two, you will get R is directly proportional to L by A. This is the relation you will get. So this is the relation you will get. So simply by removing the proportional symbol, you will get the some constant. That is what R is equal. So if I am removing this proportional, you will have to keep some constant rho. Rho into L by A. R is equal to rho into L by A. So if I want, so now you can write this. What is meant by rho? Rho means resistivity. Resistivity. Rho means resistivity. If I want the rho value, so simply this value is goes here, that is L by A is reverse. Like if A is divide is there, it is going to here, you will get, so that is what multiplication. Here L is multiplication is there. So that means simply L by A is comes here, A by L you will get. So if I wanted to write this rho is equal to R is as it is, R into, so you will get A by L. A by L, right? So what is this? Rho means specific resistivity. You can say simply resistivity. Rho is equal to R into A by L. Okay, then next, if I wanted to write inverse of this rho, 1 by rho is equal, if you should write reverse 1 by R. If you will write this L by A. So this 1 by rho is called the specific conductance. 1 by rho is called the specific conductance. So that is designated by K. K is equal to 1 by R into L by A. K is equal to 1 by R into L by A. By observing this, 1 by rho is nothing but K. K means specific conductance. Already 1 by R. C is equal to what? 1 by R. We know that. So hence K is equal to 1 by R is nothing but C into L by A is as it is. So K means what? Specific conductance. Specific conductance is equal to, so let's K is specific conductance. Very important relation. Specific conductance is what? C means conductance. C means conductance into L by A. You can call L by A is called cell constant. L by A is called cell constant of the reaction. So now simple, R is equal, R is directly proportional to L, R is inversely proportional to 1 by A. So you can say R is directly proportional to 1 by A. So by combining these two, R is directly proportional to L by A. If you keep removing this symbol, so R is equal to rho into L by A. If you want rho, so if this value comes here, you will get A by L. So the value reverse, if you will do reverse, the rho is called resistivity, that is separate. And if you will reverse this 1 by rho, reverse this 1 by R, reverse this L by A, this 1 by rho is nothing but K. So K is called specific conductance. Simply the relation is specific conductance is equal to conductance into cell constant. This is the relation. Very, very important concepts. So generally in examination point of view, what they will ask is, they will give the some conductance value and cell constant value. They will ask the specific conductance. For example, like this, if C is something, C is conductance is 5 ohm inverse, if they will ask, and L by S, cell constant is length. So generally length units is centimeters, by area units is centimeter square. Area is what? For example, if I will take square, this is A centimeters, otherwise 10 centimeters, here it is also 10 centimeters. 10 into 10, area is A square. A into A means 10 into 10, 100 centimeter square. Centimeter into centimeter, centimeter square. Like this, area units is centimeter square. If you will get cancel, so that is 1 by centimeter, that is nothing but centimeter inverse. So if L is equal, this is the question just, L is equal to 2 centimeter inverse. What is the value of K? What is the value of specific conductance? K is equal to what? Specific conductance is equal to conductance into cell constant, that is 5 into, what is this? 2. 5 into 2 is 10. 10 ohm inverse centimeter inverse is the answer. Like this type of questions they will ask in the examinations. Now we will discuss next what is the factors involving in the K. Already we written the relation, right? What is that K? Next factors affecting K, directly I am writing K is equal to what? Conductance into L by A, right? So K is specific conductance is independent of the following, independent of the following factors, independent of the following. What are that? K is independent of the conductance, independent of the conductance, and conductance reverse is resistance, it is also independent of the resistance. And K is independent of the length, K is independent of the area, K is also independent of the cell constant, that is L by A ratio. The K is specific conductance is independent of the following functions. What are the following? Conductance, resistance, L by A. So next, K is depends upon, note, this is a note, very, very important. K is depends upon only concentration. Depends upon only concentration. This is the exam point of view they will ask. So in specific conductance is depends upon which of the following factors they will ask. Otherwise specific conductance which of the following, it is not independent. So like this they will ask. So K is equal to C into L by A. K is depends upon only concentration and it is independent of the conductance, resistance and length, area and cell constant. So okay, next units, right? Units. First, units of ohm you should know. Units of resistance. Units of resistance. Resistance units is ohms. C is equal to 1 by R relation. So resistance units is ohm. So what is the C units? 1 by ohm. 1 by ohm is nothing but ohm universe. Ohm universe. So ohm you can represent it as like this symbol. Resistance symbol is ohm. Units is ohm. The symbol is like this. So conductance is just reverse to the ohm, that is ohm inverse, because C is equal to 1 by R. So hence C that is equal to ohm inverse, or you can say mho. Ohm inverse or MHO, mho. You can also say mho. And now we will discuss about what is the units of resistivity. Units of resistivity. Before going to this, you should know the resistivity formula. Then only you can write the units. So what are that? R is directly proportional to L first. R is inversely proportional to 1 by A, R is equal to, otherwise you should write R is directly, again I am writing R is directly proportional to L by A, R is equal to, if you remove this, rho into L by A, so if you want rho is equal to R into A by L. So for this units you should write. So for rho, what is the R units? That is ohms. R units is ohms, and area is what? Centimeter square, by length is what? Centimeter. You will get only centimeter, ohm centimeter. So you can say rho is ohm centimeter. And next, finally, specific conductance. Specific conductance formula is what? Conductance into cell constant. K is equal to conductance into cell constant is L by A. So conductance units is what? Conductance units is ohm universe, and cell constant units is centimeter universe. Ohm universe, centimeter universe. So one more thing, conductance units you can say Siemens or Siemens. Conductance units are Siemens. So if you will write in place of conductance, you should write in place of simple ohm universe means you can write Siemens. Ohm universe is there, you can write Siemens. For specific conductance units is Siemens into centimeter universe. So otherwise if you wanted to write ohms means what? Siemens universe, or you can say ohms means Siemens universe. Siemens universe into centimeter. So this is the concept. Just remember one, I am going to say one trick for you. If you are confused whether it is Siemens or Siemens universe, something like, just I will give one conclusion to you. Conductance is units is what? Ohm universe. Whenever ohm universe is there, simply for Siemens it is not universe. Siemens not universe. So simply ohm universe, or you can say Siemens. If something like R value is there, resistance. For resistance, ohms we will write. Whenever ohms is there, you should write Siemens universe. Siemens universe you should write. This is the units for what? Resistance, conductance, and equal specific conductance, and also resistivity. Now, what is meant by actual conductance? Conductance is nothing but what? What we discussed. Conductance is reciprocal of the resistance. So if you wanted to say definition theoretically, the conducting power of all the ions present in the solution. The definition again I am repeating. The conducting power of all the ions present in the solution. I am writing here the conducting power of. If you know this definition, you can write the definition of specific conductance, also definition of equivalent, definition of molar conductance. The conducting power of all the ions present in the solution is called conductance. The conducting power of all the ions present in the solution is called conductance. Next, specific conductance. Specific conductance. Same definition but unit area. So the conducting power of all the ions present in 1 cubic centimeter solution. 1 cubic centimeter solution is called specific conductance. The conducting power of all the ions present in 1 cubic centimeter solution is called the specific conductance in terms of CGS units, centimeter, grams and seconds. If you wanted to write same definitions in MKS, meter, kilograms and seconds. So same definition, the conducting power of all the ions present in 1 meter cube solution is called the specific conductance. This is the definitions of conductance and specific conductance definitions. Next, effect of dilution. Effect of dilution concept. So what happens if dilution will occur? What happens to the conductance and specific conductance? We will see one by one. So now, effect of dilution. Effect of dilution. Effect of dilution means what happens if effect of dilution. So Upon dilution, so first listen the statement. Upon dilution, degree of dissociation is increases. That means the number of ions is increases. Hence conductance is increases. Number of ions is increases. Conductance is automatically increases. So the statement is for conductance. Upon dilution, what happens? Upon dilution, degree of dissociation increases. Then number of ions present in the solution increases. Conductance increases. So generally if some acid is there, like something whatever it is, this is the acid, something whatever it is. So upon dilution, what happens? Upon dilution means we are adding some water to this. So what happens? This gets breaks. So in place of 2 ions we will get 2, in place of 1 ion we will get 2 different ions like this. So number of ions is increases. So number of ions is increases, conductance is increases. The conducting power of all the ions present in the solution is called the conductance. So upon dilution what happens? Degree of dissociation increases, then number of ions present in the solution increases, conductance is increases. Now what happens to specific conductance? This is the question they will ask. Upon dilution what happens to the conductance? Conductance is increases simply. Upon dilution what happens to the specific conductance? What happens? Specific conductance? Upon dilution, listen the statement. Upon dilution what happens? The number of ions present in unit volume is decreases and specific conductance is decreases. So this is the, if in previously this is the length, unit volume, right? So now right, in previously if you will thought more number of ions, if dilution means the quantity is increases, ions gets distributed throughout the solution. So now same in this area, previously it is 2 something is there, now the, because the volume is increases now, volume is increases means if only particular area, the specific the particular area number of ions is decreases. So specific conductance means what? Upon dilution the number of ions present in unit volume is decreases and specific conductance is decreases. This is a statement issued by heart. Simple statements. Next, equivalent conductance. Equivalent conductance. Equivalent conductance, right? So you can represent with lambda C or lambda equivalent. These are the representations for this, right? So what is mean by equivalent conductance? The conducting power of same definition, but in place of 1 cubic centimeter you should write 1 Gen. Gen means gram equivalent weight. So the conducting power of all the ions present in 1 Gen of the solution is called the equivalent conductance. Equivalent conductance. So for let us say for 1 Gen of the solution, for 1 Gen of the solution in 1 cubic centimeter volume, so that is nothing but lambda C is equal to 1 cubic centimeter is nothing but we can say K, specific conductance, right? So actually directly we can write lambda C is equal to K into 1000 by relation with normality is N. This formula you should by heart. Just I will explain some little concept for this. 1 Gen of the solution in 1 cubic centimeter is lambda C is equal to K. If same 1 Gen of the solution in V centimeter cube, same statement, 1 Gen of the solution in V centimeter cube, lambda C is equal to K into V. K into V. Lambda C is equal to, what is the K units? K is conductance, ohm universe into centimeter universe. Centimeter universe. What is the volume? Centimeter cube. Centimeter universe, centimeter cube, minus 1. Whenever bases are same, you should add powers. Minus 1 plus 3 is plus 2. You will get lambda C is equal to ohm universe into centimeter square. Centimeter square. This is the equivalent conductance, lambda C. So if I will write including normality, the relation between the equivalent conductance, so you can say simply lambda C is present ohm universe, centimeter square we got now. So for equivalence means you should write equivalent universe. So because lambda C is equal, I will write this. So general definition lambda C in CGS units. CGS units, lambda, very very important formula. Lambda, don't go for theory, directly I am writing. Lambda C is equal to K into 1000 by N. N means what? Normality. This is the CGS units. So lambda C is equal to, what is the K? Ohm universe into centimeter universe, nothing but we got centimeter square. Centimeter square into this normality is 1 by equivalent. You will get equivalent universe. This is the units for lambda C. Ohm universe, centimeter square and equivalent EQ, equivalent universe. If I wanted to write MKS units, same you should write, but 1000 is comes divide. That derivation is not required for you. Lambda C is equal to K by 1000 into N. 1000 into N. Units are in meters. In place of centimeters, you should write ohm universe, meter square and equivalent universe. This is a general thing, but we are not using this equation most of the times. The important equation is lambda C is equal to K into 1000 by N. Next, similarly, molar conductance. Molar conductance. What is molar conductance? That is mu C, or you can say mu molar. Mu molar conductance. Same, the conducting power of all the ions present in the 1 mole of the solution is called the molar conductance. The directly I am writing mu C is equal to K into 1000 by M. K into 1000 by M. M means molarity. Units is same. Ohm universe. Here centimeter square. For molarity, mole universe. This is the units you will get. This is the units you will get. Next, relation between what? Equivalent conductance and molar conductance. So what is the relation? Lambda C is equal to K into 1000 by N for equivalent conductance. Mu C is equal to K into 1000 by M. So if you want to write lambda C by mu C, what happens? Simply this is divided by this value. So lambda C by mu C I written here, that is equal to K into 1000 cancel. M comes upside and N comes downside. You will write M by N is the relationship. Lambda C by mu C is equal to M by N is the relationship. So 1036. Next, last concept I am going to discuss. Variation of equivalent conductance. Variation of equivalent conductance. Equivalent conductance with concentration. Equivalent conductance with concentration. With concentration. So how variation of equivalent conductance changes with the concentration? So for one point I forgot that. So both note lambda C. So that is lambda C means equivalent conductance is increases upon the dilution. Same, upon dilution molar conductance also increases. These 2 points you should by heart because it's very very important for the competitive exams. Lambda upon dilution equivalent conductance increases and molar conductance is also increases. So now we will discuss about variation of equivalent conductance with concentration. So first I will write the some otherwise first before this lambda 0, or you can say here lambda 0 means equivalent conductance at 0 concentration. These are the terms you should know. Equivalent conductance at 0 concentration, or you can say lambda infinity, or lambda infinity means equivalent conductance at infinity dilution. You can say 0 concentration or equivalent infinity dilution, both are same. Equivalent conductance at infinity dilution. Infinite dilution. These are the terms you should bear because these are very very important in the Debye-Hückel equations. Lambda 0 or lambda naught. Equivalent conductance at 0 concentration. So now we will come into our topic, variation of equivalent conductance with concentration. First I am writing the graphs. So this is lambda C versus concentration. Lambda C versus root C. Lambda C versus root C. Right. This is strong electrolyte. This is weak electrolyte. Right. This is what? Lambda naught or lambda infinity. Lambda infinity. This is lambda 0 or lambda infinity. So this is what? Strong electrolyte, weak electrolyte. In exam they will give this is A, this is B. Which of the following is strong electrolyte? Options they will give like this. And the statement for both strong electrolytes, for both strong electrolytes and weak electrolytes, both strong and weak electrolytes, upon dilution equivalent conductance increases. This is a point you should keep in your mind. For both strong and weak electrolytes, upon dilution equivalent conductance is increases. So for lambda naught, this is the lambda naught or lambda infinity, lambda 0 or lambda infinity, that can be calculated for strong electrolyte by plotting the graph between the lambda c versus root c. So because this is the only lambda c versus c, so you will get approximate graph, that is strong and weak. For lambda 0 or lambda infinity value, to find out this value, we should draw the graph between lambda 0 or lambda infinity, can be calculated by plotting. This is very important, lambda c versus root c for strong electrolyte. This you should write for strong electrolyte. Same, but lambda naught, lambda 0 or lambda infinity cannot be calculated by plotting lambda c versus root c, because this is not touches here. So simply you can remember like this. So lambda 0 or lambda infinity cannot be calculated for weak electrolytes by plotting the lambda 0, lambda c versus root c. So but this lambda 0, here you can say lambda 0 or lambda infinity can be calculated indirectly by Kohlrausch law. So that we will discuss in the next class. So just this is the variation of equivalent conductance with concentration. Just simply it is for both strong and weak electrolytes, upon dilution equivalent conductance is increases. Lambda 0 or lambda infinity can be calculated for strong electrolytes by plotting the lambda c versus root c for strong electrolytes. Lambda 0 or lambda infinity of a weak electrolyte cannot be plotted by drawing lambda c versus root c for weak electrolytes. So these are lambda 0 or lambda infinity value can be calculated indirectly by Kohlrausch law, that we will discuss in the next class. Thank you. If you like my video, subscribe and share to your friends. In next class, if possible, I will discuss like inorganic and solid state topics also. Share to your friends. Thank you so much.